Hi all, my name is Gulshan Banu, working as an assistant professor, AI and DS department. Today I am here with a new topic called constraint satisfaction problem and constraint propagation. Now, what is constraint satisfaction problem? It is nothing but you are being given a problem and you have different constraints in it. You have to satisfy all those conditions and all those constraints that is being provided for it. In this, there are three different main things that is being dealt with, that is variables, domain and constraint. Okay, we will see like what is variable, what is domain and what is constraint in the next slides. Now the example of this constraint satisfaction problem is script arithmetic problem and map coloring problem. Okay, now what is the script arithmetic? Script arithmetic is nothing but you have to convert a readable plain text into non-readable cipher text. Okay, now what are all the constraints that is dealt with it? The different constraints that is dealt with it is the value should be unique and it should not, the digits that you are taking should not be more than between, that should be always between 0 to 9 and the starting value can never be 0. Okay, and you should have always one solution at a time and the addition of those numbers should always be even. In case if you carry any kind of carry value, the next step of the value should always be, the carry value should always be 1. Map coloring is a technique in which you will color or you will define that the region should be in this particular format or this different color or something. In this, you should not have the neighboring regions or the adjacent regions as the same color. Okay, now we will see how it is. When you take this different kind of continent, you have different countries that is related to it. The different countries that is related to it is called as a variable. The colors that you specify is called as the domain. The conditions that you provide is called as the constraint. Now, when you are coloring each and every domain, you will be provided with many backtracking techniques. That is, first, the continent is it is not colored. So, you are trying it with red, then green, then blue. Now, you are taking the red color. In that red color, the adjacent countries should not be of the same color. You are trying it with either green or blue. Now, when we take it as green, the next adjacent region can either be red or blue. After that red or blue, it can either be blue. After that blue, it can be green. So, this is the process of how the coloring pattern is followed. If this is not satisfied, you have to backtrack it and again do it. So, what is this constraint graph? Constraint graph is nothing but the nodes or variables, arcs are constraints. So, when you are converting a continent or the representation into some kind of arc or some kind of mapping, it is called as a constraint graph format. Okay, in that constraint graph format also you will follow the same thing, that is, when you are coloring the different constraint graphs, the adjacent nodes should not be of the same color. Now here there are some variations on CSP, that is the discrete variables. In that discrete variables you have three different types, that is finite domains. In that finite domains you have continuous domain also. Okay, finite domains, infinite domains and continuous. Finite is you will have some finite values. Infinite is you will not have any kind of infinite values, and continuous domain is the process will be continued then and there. The example of this infinite domain is job scheduling. We will see like what is job scheduling is. Job scheduling is very easy, like you have studied in operating system. It is like a process which is being done in a very specified duration, should be completed. Only after that the next process should be done. Now there are different constraint types, that is unary, binary and higher order. Unary constraint is when it is dealt or when it is restricted with single variable, it is called as a unary constraint. When you deal with two variables, it is called as binary constraint. When you deal with more than two variables, it is called as binary constraint. Now this global constraint is something that is involved with arbitrarily process. Arbitrarily is like n number of process that is being evolved with it, is called as a global constraint. Now in this global constraint propagation, you have an algorithm that can either be done with a searching process or you can do a specific type of inferences. Okay, now this is how the constraint propagation graph or constraint propagation diagram looks like. You should follow the different conditions, the different constraints, the different variables and the domain that is being provided through it. Now this local consistency is of 4 types, that is node, arc, path and K consistency. When you are dealing with a single node and it has a unary value, it is called as a node consistency. Here X is the node that you are dealing with, so D is the domain and C is the constraint, and delta D is like the values that you are being assigned. Say for example, when it is defined as V is V should always be greater than or equal to 3. It should be included with only 1 to 3 values. This is all about node. R consistency is like you are following an R format, or when you are dealing with binary values and you are dealing with R, that is mapping. It is called as R consistency. Now, what is this path consistency? Path consistency is something that is being dealt with the different paths that you are following. Now this K consistency is something that is related with all these consistencies and all these node consistency, that is node, arc and path together make it with the K consistent variable. So this is all what about the constraint satisfaction problem and the constraint propagation is all about. So in the next video I will be meeting you with a very different topic. Thank you.